Hello everyone. Today we are going to discuss about the rotating magnetic field in case of a three-phase induction motor. Now, to understand about the rotating magnetic field, we have to know first the internal construction or the construction of windings in a three-phase induction motor. For our ease of understanding, we have taken a six-pole machine and where we have three pole pairs. So we have made the connection like this. This R phase is connected over here, and this line goes through the opposite pole and connects to the neutral over here. Similarly, the Y phase over here is connected to the pole just 120-degree apart, mechanically 120-degree apart from the R phase. So the angular difference is 120 degree, right? And the connection is same. The other terminal goes to the neutral. And for the third case or the third phase, which is the B phase, we have connected this in the similar way, and this again goes to the neutral, and this is also 120-degree apart from Y and R both. So we can say that the windings are connected 120-degree apart from each other, just like this. If this is the R phase, this is the B phase, they are 120-degree apart from each other. B and Y phase are 120-degree apart from each other, and R and Y phase is 120-degree apart from each other. Now let's talk about the signals that or the AC signals that will be given to these R, Y, and B phases. Right. So to know that, we have already discussed in the class that this mechanical angle and electrical angle concept, right? So electrical angle is just half to that of the mechanical angle. So electrically they are 60-degree apart with each other. Electrical angle. So sine 60 degree is root 3 by 2. The value of sine 60 root 3 by 2, which nearly stays as 0.8 something, right? Which is near to 1. And sine of negative 60 is also near to minus 0.2, right? 0.866 as far as I remember. So here we can see that, let's say, the R phase is starting from angle 0, right? Or value 0. So now this R phase is starting from 0 and continuing with the signal, and as the other phases are 60-degree apart or electrically 60-degree apart, so the values are nearer to 1. So the value over here will be 0.866, and here also the value will be minus 0.866. So from these two, the Y phase and B phase will be starting, right, to keep the three phases 120-degree apart from each other. Okay. So this is the concept of formation of three-phase sinusoidal waveforms. Now, to understand it well, we have eliminated all these connections and just shaded the poles where the blue or the B phase is there. We have shaded that blue. The yellow phase, we have shaded that yellow, and the red phase, we have shaded that red, right? Now let's see how does the formation of this uh, poles happen. Now let's consider or take consideration that if the phase or the phase signal is in the positive half cycle, then we will consider that as north pole, and if it is at the negative half cycle, we will consider that as south pole. So this is a consideration. This can vary. You can take the other, take the vice versa also. We can take the consideration as if if it is the signal is in the positive half cycle, we can take this as south pole, and the reverse also. So that is up to your consideration. Both of them work similarly. Mm, now, let's say that the R phase, let's take the R phase first. So in the first instant, the R phase goes to the positive half cycle, right? R phase is in the positive half cycle. So R phase, from where it starts, it will produce a north pole in this pole, right? So similarly, as we know the formation of a solenoid, if this is a north pole, the obviously the opposite pole will be south pole, right? So there is a formation of north pole and south pole due to the R phase, as long as the polarity remains same. So here the polarity is positive polarity. Now in the second case, that is the Y phase. Now see, the Y phase is 120-degree apart, right? So the Y phase starts from here, and now so it is in the negative half cycle. So the negative half cycle means it will produce a south pole over here, and obviously to form a solenoid we have to consider this as north pole in the opposite direction. Now in the third case, this is the north pole. That means B is starting from the positive half cycle over here. So this is the north pole, which is similar to that of the red one, although the phases are different. So there is a formation of north pole and there is formation of south pole, right? So this is for our first instant. Now in the second instant, obviously the polarity of these signals RYB will going to change, is going to change. Now mm, so if this is carrying this is a carrying a current which is having a polarity, negative polarity, then now in the second instant this will be carrying a current which is having a positive polarity. So here is the positive polarity. So the second instant is in this phase. Until and unless it crosses zero, the first instant happens. So this can be considered as our first instant. This can be considered our second instant. This can be considered our third instant, and so on. Right? So this is our first instant. This is our second instant, and this is our third instant. Right? Now here we can see the south pole has changed into a north pole, right? And similarly for all the cases, this will be changing to south pole, this will be changing to south pole, this will be changing to north pole, south pole, and north pole. Now what we see that is uh, we consider these poles as rotating. So if we place these previous poles in the second instant, we can see that the previous pole will is north. We have placed this north over here, south over here, again north over here, south, north, and south, right? This is according to the previous one. So we say we take this as a rotation of poles, and that's why the topic is called rotating magnetic field, rotation poles. So you can take this as a clockwise rotation or an anti-clockwise rotation. That is up to you, but depending on the polarity, the clockwise and anti-clockwise rotation varies. Uh, so we will discuss that later. But for this instant, let's take that this the poles are moving in a clockwise direction, right? So poles are moving in a clockwise direction. So this north pole is in the previous instant. Now this north pole is moving or becoming this north pole just adjacent to this pole. So this pole is shifting here. Now the south pole is shifting over here. This north pole will be shifting over here, and this south pole will be shifting over here. Again, this north pole will be here, and this south pole will be here. So although there is no movement in the fixed poles due to the sinusoidal waveforms, the change in the sinusoidal waveforms, the poles then seems to be rotating in a particular direction. This we can do in the opposite direction also, depending on the polarity. Uh, so this can be seen as a rotation of the magnetic field that has been produced in the poles. So that's why it is called a rotating magnetic field. Now let's see if this uh, consideration or this theory applies to the third instant or not. So if this applies to third instant, that means uh, this this theory actually works, because we cannot deduce to a theory in the second instant, in just two instants, right? So here the previous instant was north, right? So this will be south. For the previous one, I'm making it around circles. Mm, so this one will be south, this one will be north, this one will be north again, this one will be south, and that's it, right? So according to this, uh, the direction of rotation, this south will move over here, this north will move over here, the south will move in here, north will go over there, south here, and this north again to this one, right? So the new thing or new poles that will be induced in this instant will be, this is south, this is north, south, north, south, and north, right? So these are the composition of poles. Now we can see that the composition of poles is quite similar to that of the first one, right? So south here, north here, south here, north here, north, south, north, south. This is north, south, and this is also north, south. So quite similar to the first instant. Now let's go over here in the signal thing. The first instant looked like this, where the red and blue are in the positive instant. Now here we can see that the red and blue are in the negative instant, right? And the yellow is in the positive instant. So the theory is actually working because as there is a rotation of poles, these polarities also changes. So the red over here and the blue over here comes to the negative, and the yellow over here, which is in the positive, is previously in the negative section. So there is a rotation of polarity also happens. So this is why uh, this phenomena is called rotating magnetic field, right? So that's all for today. We'll discuss about the three-phase induction motor in our next classes. Thank you. Stay safe.